Alright, I've had a few people ask for a quick review of matrices of our first objective that we've had so far. I'm going to go through this fairly quickly, and I'm going to skip some major parts of our packet. Oops, sorry, saw that was on there. Let's get that off. There we go. Alright, so now on our screen I have just our note pack for our matrices unit, Unit 3 matrices. We're looking at using it to represent data, identifying an element, creating a matrix, and creating matrix from a system of equations. A matrix is just an ordered set of data. Anything that we see that's in a table like this is technically a matrix. We just need to put brackets around it because that's part of our definition of a matrix. It is an ordered set of numbers in a pair of brackets. An arrangement. Sorry. Of numbers in rows and columns between brackets. And a matrix element is just one number in a matrix. Now we can use matrices with something giant like this with our Detroit Tigers season ticket pricing. I just want to skip right on down to the dimensions of a matrix. When we look at the dimensions, we want rows by columns. So we write that by as an X. So our number of rows is what we're seeing here. Here's row 1 and row 2. So we have 2 rows. When I see how many columns we have, I have 1, 2. I have 2 columns. So I have a 2 by 2 matrix. In example B, I have just 1 row. And I have 1, 2, 3 columns of information. So I have a 1 by 3 matrix. 2 rows. 3 columns, 2 by 3 matrix. My goodness, I wrote a 2. And here I have 3 rows, 2 columns, a 3 by 2. And we're going to use that information the same way that we do dimensions of a matrix. How many rows and how many columns. To start identifying individual elements within a matrix. We name a matrix by a capital letter. We name each of its elements within a matrix with a lowercase of the same letter. So we know that element K32, that's how we read that, is in matrix K, and we're going to row 3, column 2. So in the same order as our dimensions, rows and columns, we name our elements. So I'm going to go to the 3rd row. I'm going to find the 2nd column in that row, the 2nd element in that row, and I find that it's a -4. Part B asked me to go to find element K23. It's telling me to go down to the 2nd row, and now I'm going to count over to find the 3rd element. The 3rd item in that row is a +4. Element 3, 3. 1, 2, 3rd row. 1, 2, 3rd column. 7. Element 1, 1. The very first thing in the very top left. So that's helping to find an element within the matrix. Here is some information to help you out with that. If I'm looking for something like number $29, how it shows up twice in the matrix on the previous page, that Tiger season ticket thing. And I need to name that position for both of them. Let's see, I'm looking for $29 here on the front page, so I'm going to flip on back. To find $29, I'm just scanning to see if I can find it. Ooh, I see it one time here. I'm going to count the rows down and then columns over. 1, 2, 3, 4, 5, 6th row. And 1, 2, 3, 4, 5th column. So one of my elements is 6, 5, and I need to name it. I'm going to call it matrix M. I don't know why. Just because M starts with matrix, matrix starts with M. So I found one of them, number $29. I need to find the other $29 and name it. And I see it right here. So let's count rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th row and the second column. 11th row, second column. Now I'm going to add something a little different in here because we're looking at matrix M11, 2. Now I have to be careful because it's hard to tell these numbers apart. I want to make sure that it doesn't look like it's row 1, element 12. So I'm going to put a comma between those. So sometimes we write these with a comma between them, sometimes we just write it as a 6-5. Now we can also turn any data that we know into a matrix. This one tells me it needs a 2 by 3 matrix. That means I need to have 2 rows and 3 columns. The only thing that I have 2 rows of, it says let the rows represent wins and losses. So here I'm going to have wins, here I'm going to have losses. And my columns represents each student. I have 3 students, Ed, Joe, and Lou. Here's Ed, here's Joe, here's Lou. And count up the number of wins that Ed has. Wins are check marks. 1, 2, 3, 4, 5. I see 5 wins. 2 losses. Joe has 6 wins and 1 loss. Lou has only 3 wins and 4 losses. It's not quite a matrix yet. Remember, a matrix is an arrangement of data inside brackets, so we need those brackets on the outside. Sometimes this can seem a little bit silly because to make this into a 2 by 3 matrix, well, it already has 2 rows. And it already has 2 columns. So to write matrix N, I would just say N equals, I'd have that bracket, and it would just be exactly like we see in the data table. Capital letter out front, brackets, data inside. Last thing that we'll cover in this first objective is how we do something called an augmented matrix. It's just a way to represent a system of equations as a matrix. So our example here shows us that we're just going to take what was 6x and 2y and 10, and we're going to just rewrite it without x's and y's. We're still going to use that equal sign. So first thing to make sure, we need to line up all of our variables, our equal sign, and our constants. That's just numbers. So they need to stack, just like we have here, x's and y's and constants. And then we're just going to rewrite it like this. We put a bar in place of the equal sign. We don't write any variables, and we keep them in 2 separate columns like this. Yipes. That's recording. That's not done. Sorry. There we go. So to change these things, I think you'll see how nice it is to change a system of equations into an augmented matrix. First things first, I'm going to put some numbers here so that I remember that that's 1x. All right, if it has a blank here, that's when the only time we're going to use a 0, like this one's got a blank space. Otherwise we have, so I have a positive 1x, that means I'm going to put on a positive 1. I have a minus 5y, that means I'm going to have a negative 5 in the next column. The equal signs turn into a bar, and on the other side of the bar I have the number 4. Now for my second equation, I see I have a negative 2. This one's awfully hard to read. I'm going to say that that's a plus 1 because I can't quite tell. Positive 1 going on here, so I'm going to put a positive 1. And on the other side of the bar, I have a positive 1 as well. Put it in brackets, it's good to go. Let's try this next one. I see a positive 1, a negative 3, an equal sign bar, and a 5. Positive 3, negative 1, negative 1. Put it in brackets, set to go. Try this next one, hit pause if you need to. I'm going to just drop the answer right on you. Check that you have a bar, check that you have brackets on the outside, check that you got the right answer, looking good. Just like we could turn a system into an augmented matrix, and we can do these of any size of system. We could have 10 equations if we wanted to. We could have 8 variables across if we wanted to. So we can do these of any size. We can also go the other way. If we're given an augmented matrix, we can simply turn it into a system. To do that, we just get to pick variables, and everything in the column gets the same variable. So this first one I'm going to use the same old boring x's and y's. So everything in this column gets an x variable, everything in this second column gets a y variable. My bar is replaced by an equal sign for each equation, and my numbers go on the opposite side. So I have a 5, not only a 5, but a 5x. This is a positive 7, so I'm going to add that positive 7 and add the y. Here I don't have any x's, so I can put 0x or I can just leave it blank. But I have a negative 8, so I would have a minus 8y. Now again, we can use any size augmented matrix and any size order system of equations. And I can assign any variable I want to unless it tells me what I need. So this one we're going to choose something, I don't know, different. Let's do C and M and P. So everything in this first column is going to get a C variable, negative 1C, 7C, 0C. Everything in my second column is going to get an M variable, 0M, 2M, 1M. Notice I'm putting plus signs if they're a positive to keep them as a system of equations. Third column gets a P. I see a positive 3P, a negative 1P, that's a minus 1, positive 2P. The bar turns into equal signs, and my numbers stay the same. So we've written a system of equations. Systems get a bracket out in front. Forgot that one over here. So now we can turn matrices into systems and systems into a matrix. Last but not least, I'll show you a quick little coding thing that we may have done in class. If you need a little help with this, it's just to help you practice identifying elements. You'll notice each one of these things leads you to an element here in matrix capital A. So this first one tells us to go to row 4, column 8. So think of it like playing Battleship. You go down first and then you go over. So row 4 puts me here in this row. Column 8, 1, 2, 3, 4, 5, 6, 7, 8. And so where I'm looking at where these two things would intersect in this row and this column points me to the letter capital I. That's what we're going to put here. Row 3, element 2. Row 3, second element is a T. Row 1, element 8. Row 1, I'm going to count to the 8th element. 1, 2, 3, 4, 5, 6, 7, 8. Lowercase h. Keep on working on the same thing to fill it all out. Good luck.